To introduce myself, I'm Devyani Khare. A lot of you know me off of Twitter, maybe largely for the bird content and insect content and things like that. But I finished my master's in geomorphology, and as luck would have it, I wasn't really able to work in the field. I've done a lot of other things besides. So this was a really interesting chance to kind of share some of my enthusiasm for why I chose the subject. Most of my friends think I chose it because, well, it's just so difficult to say, and then it just makes for awkward conversation. But you'll see that there are a lot more reasons why I chose geomorphology, and I'm hoping that's something you can take away from this session. Um, so let's dive right into it. I guess simple off the top of the head, geomorphology is nothing but Earth plus change plus the science. But we're thinking of this very literally, the changing forms of Earth and the science behind it. For geomorphology, surprisingly, there's another definition that really works. We're looking at four geospheres as is. So one is the geosphere itself, it's the Earth. One is the hydrosphere, all the water that's on Earth and the way it interacts. Then there's the atmosphere, which has all your air components all the way till the air disappears into nothing. And finally, you have the biosphere, everything living, of which sadly we are quite a destructive part of that. And geomorphology then is the interaction of these four spheres. And when they interact, they end up shaping the landforms, the surface of the earth as we see it, into a whole range of shapes. And that's what geomorphology is trying to understand. It's trying to understand what are the surface processes, how did they originate, what might be the composition beneath some of these features, and how did they evolve over time. So, not just in the past, but things in the present, and finally, how they might look like in the future. But I think predictive is not really such a big concern with geomorphology, it's largely looking at the past. And while we're studying the evolution of landscapes, it of course needs to focus on the agents responsible for these processes. So I think this is something we studied often enough in school, but I'm just going to run us through it because this is an introductory session. So a very basic diagram. I hope it's legible. So geomorphology is looking, well, at two kinds of earth movement processes. One that they believe happens from within the earth. Um, Very slow movements, such as when continents are built because of the plate tectonic shifting, or when mountains are built because there's crumbling and folding that happens, or then a very rapid rate of earth movements, such as volcanism and earthquakes. And then you see how many different landforms there are, which are formed solely with endogenic processes. But because these occur over either longer periods of time or sudden movements happen suddenly, over time there are slower processes that are shaping landforms at a slower rate, but a more definitive rate of sorts. And those are your processes of weathering, erosion, and deposition. So, by and large, the agents for these processes are similar. You have water in two forms, either running or groundwater. You have the movement of ice in the form of glaciers. You have sea waves, currents, tides, a whole gamut of that. And then you have the winds. Of course, in different geographies, different agents have more or less of power to be shaping and sculpting landscapes. In the tropical regions, for instance, the rivers and the rainfall are the greatest sculptors of landforms. And similarly, in the northern stretches of India, you do have some glacial activity. Along the coast, I think 4,000 kilometers of it, you also have a lot of coastal activity. So, depending on your geography, different movements take up different um, amount of time. So, Again, to delve into some of the agents, water itself in all its different forms has a lot of impact on the way the landscape is shaped. These are agents you're familiar with: rivers, rainfall, other kinds of precipitation, could be snow, could be sleet, sudden, and anything that results in flash floods, glacial ice, sea waves, their currents, their tides. Similarly, tectonic movements are also very rapid agents that shape the landscape. Among biotic, we have to consider the slow chemical and biological weathering of plants. At some point in time, corals also shape, well, land masses in a way. The theory of formation of islands, so what's known as atolls, which Charles Darwin had propounded at some point in time. And finally, humans. So we are, with a lot of our earth moving machinery, our constructions, our damming, all of this, we're shaping the landscape. And finally, there's either wind or land movements themselves. Voila. A lot of times, some of the basic concepts of geomorphology, such as weathering and erosion, are used interchangeably, but they're not very interchangeable. What weathering is simply the physical disintegration of any kind of material. And when it breaks down into smaller components, such as sediment, and sediment can be of different kinds as well based on its size, that is known as weathering. So just temperature, rainwater, vegetation, they're all agents of weathering. They break down material as we know it. Then there's erosion, where your broken down material is physically transported from one place to another. And the agents responsible for that are moving agents: ice, wind, rivers, with rivers as the most prominent in tropical areas. In temperate areas, also sometimes they have a lot. Even rainfall sometimes, depending on how heavy it is and the fact that it comes through seasonally, can cause erosion. And finally, there's deposition. And your landscapes usually bear traces of one or other of these processes, or more than one, when all of the sediment that's been transported is actually dropped off at a particular location and it forms these different landscapes. Okay. Also, what's the difference between landforms and landscapes? It's pretty simple. A lot of landforms are created, as we said, mountains or volcanoes or mesas or harbors, delta. All of these are different landforms. And when you're looking at, let's say, a depositional landscape, many such features form a landscape. So when you're trying to understand the process of a river, the river will go through 3 or 5 different stages, and that's the river landscape that you're talking about. So this is pretty basic, and this I felt was needed to be covered before I can jump into what geomorphology is at the heart of it. So there are some basic ideas that are the foundation for geomorphology, and as the subject has evolved, these have been contested. So there are some people who hold to with these tenets, but specific cases for, let's say, river erosion or coastal erosion sometimes may deviate from these. So what are the tenets? The past is key to the present. In most every topic, every paper, every research writing on geomorphology, this line comes up. What it's trying to say is that on a particular landform or a landscape, even, the processes that operated in the past continue to operate at the present. The intensity at which they did is similar, and that's why what you see today is often key to what was there before. This might seem contentious for now, but we will deal with that later. So basically, the past is key to the present. Whatever features we see today can indicate what kind of climate, what kind of rock, all of that that existed in the past, and why both landscapes were shaped as they are. Form implies process. Any landscape that has a particular set of physical or chemical properties is usually a result of some kind of process. It could be just the weathering. It could be the agents that are responsible. Has a river taken away a lot of the nutrients from soil and has it transported it away, leaving behind bare, barren rock? In India specifically, you see something like that across the western coast. The laterite plateaus that are there were river formed at some point in time, where the river dissolved all the nutrients and carried them downstream. And finally, all that you were left with was hard rock, a lot of silica, aluminium, and iron. And that iron is what gives it the reddish tint. And finally, from a very holistic point of view, landscapes strive towards equilibrium. Just like nature doesn't like vacuums, right? Nature abhors a vacuum. Landscapes are trying to look for equilibrium. So, in terms of geomorphology, the role of the river is to tear down the ambition of mountains and bring it to the level of the sea. And to do that, the well, the rivers end up tearing down or weathering a lot of the material, eroding it and depositing it closer to the sea so that at some point in time, the mountains and the sea can be at par. Similarly, with coastal features, the coastline is a barrier to the waves that keep lashing at it. So, what the waves are trying to do is cut down on that coastline so that it's a smoother gradient into the ocean. Now, that's a slightly metaphysical way to think of geomorphology, but it's very interesting because I had a professor who would personify rivers in that sense to say, oh, the river does this work, or even the agents. What is it that they're trying to do? They're trying to achieve this sense of balance. So every geometry that you see, a plateau, a steep sided cliff, all of this is a constant push and pull between the materials that there are, what kind of rock, what kind of biota exists on it, and the processes that are shaping the landscape. Leave that for now. We will tackle those questions later. So, when we look at geomorphology as well, a toolkit to kind of see what it is that it can tell us about landscapes, it's not just a cold subject, in my opinion, theoretical, which is outdated. But somehow, using the tools of geomorphology, you can read landscapes. And what can you read within it? So, while I have focused on a lot of different agents, knowing that in India, rivers are some of the most powerful, and I'm personally very fascinated by the roles rivers play in landscape formation, I want to give you just a little bit of insight into how you can read a river landscape and know that this is something like a toolkit that can be expanded for sea waves, glaciers, all of that, right? So, how do you read a river? So, first off, how do rivers carve landscapes? Right? What is the power? What is the energy that they have within them? One is the discharge. How much water does it really have? The water can come from rain, the water can come from glaciers. What amount of water? And then how powerful is the river to weather, erode, and finally deposit all its material. Ultimately, whatever the discharge is can get negatively affected if the river has been dammed, if there's a diversion, if we're extracting or abstracting water from it. So, how much water flows through a river is one of its key strengths. Based on the discharge or based on the source of water, if it's a glacial melt or if it's rainwater, and for how long does it fuel the river of sorts, you can have either a perennial river or a seasonal river. And based on that, you might have the landscape that is being formed throughout the year or just for a few months in the year. And finally, based on the discharge, you also have the sediment that the river is carrying. How big of a rock can the river carry downstream? And then the rock kind of grades down into pebbles, sand, clay, and finally silt. So the rocks, as you'll see also within the river channel, has a lot of impact, have a lot of impact in breaking down the landscape. There are certain features that you identify solely on the basis of the size of the rock that the river carries. Anybody who's been to Hampi, you'd see that in the river stretches of the Tungabhadra. Now, this is something you see in other rivers as well. Hampi is just the example that comes to mind most immediately. You see these pothole kind of structures. Looks like the bedrock has been scalloped out, like a dollop of ice cream that's just been removed from the rock, and the river flows on. And this you see because the Tungabhadra shrinks during the summers. And those formations are nothing but rock that had gotten trapped in an eddy, in a spiraling current of river, and that's how it just kind of carved out that landscape. And these pothole formations are seen in different rivers all the time. So that's a component of the sediment, and that's also a component of the discharge. How heavy was the water flow to be able to carry rock of that size? So where does the sediment come from? And geomorphology, especially that of the river, is largely concerned with these three layers of sediment production. Where mountains are, there is a lot of weathering of bedrock. Sometimes there are extreme events like volcanic eruptions or landslides, and that's what causes hard, coarse kind of sediment to form in the upper stretches. And based on the force of the river, there'll be a transfer to the mid elevation by rain, river, just the slope itself, so gravity, and finally any kind of flooding. And ultimately, when that entire action has been worn down, has slowed down a little, the sediment is heavier than the river is able to carry. So when she becomes too weak to continue with this sediment is when she deposits that amount into the lower elevation areas, allowing the river to meander, allowing plains and deltas to be formed before she finally meets the sea. So when we're looking at rivers, I know that a lot of times we cannot look at a river as an entire river. We cannot really see all of its tributaries, its distributaries, and kind of identify what patterns there are. But sometimes when you walk along a river, you get a sense of exactly what kind of flow it has. So if we were to look solely at river patterns and try to guess what the underlying rock is, and this works really well even in Google Earth, as we'll be doing in a bit. So each of these terms needs to be thought of in terms of, if a river is straight, why is it straight? What about the geography is not allowing the river to weave its way through, right? To meander. And it's usually because there's a structural weakness. There's some kind of crack or a fissure or a gorge that it has plunged into, and the rock is too hard for it to carve out, so the river just flows straight on. Similarly, if a river is dendritic, as you can see, like forming these brain-like neuron patterns, you know that there's pretty uniform terrain. No rock is posing any more of resistance to the river, and the rocks just easily erode, and the river takes on its natural shape of just forking, just deviating. The way you would pour water on any flat surface, right? It never flows in a straight line. It usually starts breaking off a little. That's what dendritic rivers are. The landscape is easily eroded. Trellis formations, again, you have what look like grapevines, right? They have a bit of parallel and they're interwoven. So there are sedimentary rocks. So each of these river patterns indicate something about the geology. Um, Radial patterns, if you're looking at it from the top, if all the rivers seem to originate from one place and they're flowing away or into a particular area, you know that there's a volcanic structure. If the rivers are flowing away, the volcanic structure is most likely a dome or a flat-topped sheet, and then the rivers flow off of it. If it's centripetal, you know that either the volcanic depression or it could be any kind of hard area, and all the rivers are meeting that depression. Um, And finally, why do rivers meander? Part of their action is carrying sediment. And when they carry sediment based on what discharge they have, they may not really always have the power to carry that through. In the mountains, they have the force accompanied by, of course, the steep slopes, and that's why they are able to gush down slopes rapidly, and the sediment is carried down. But the minute they enter the mid elevation zones, they slow down. You have velocity, but you also have some amount of deposition that's happening. And reading river channels is also a good way to get a sense of where the river is coming from, where it's going, and what kind of incline there might be.